Somewhere in the depths of space, there is a world that never knows the real night. There is no usual alternation of day and darkness, because there are always two suns burning above the horizon. They don't just illuminate the surface, they lead a complex, eternal dance of gravity, and the planet moves around them as if caught in a perfect but dangerous orbit. This planet belongs to a rare type of worlds that are called circumbinaries. It orbits two stars at once, not around one like Earth, but around a binary system, where two stars are bound by a common gravity and move around a common center of mass. Their light intertwines, creating strange shadows that are never the same twice. The orbit of such a planet does not resemble the usual circles or stable ellipses. It is complex, slightly fluctuating, as if the cosmos itself cannot decide where to lead it. Sometimes the planet is closer to one star, sometimes to another, and sometimes both stars are almost in the same line. And then the surface is flooded with a particularly bright, almost blinding light. One of the most famous such worlds is Kepler-16b, a gas giant discovered in a system of two stars. It is not solid, but it is precisely such worlds that have proven that double sunsets and double sunrises are not a fantasy, but a reality of the cosmos. In its sky, two stars slowly shift relative to each other, and their light never matches completely, creating an ever-changing lighting pattern.
In such systems, gravity works differently than in single-star systems. Two stars create a variable field of attraction, and this affects everything around them: the movement of the planets, the stability of orbits, the distribution of heat and energy. Even a slight shift of one of the stars can change the climate of the entire world. If such a planet is too close to one of the stars, its surface overheats on one side, while the other remains cooler. If the orbit is more distant and stable, the climate becomes complex, but potentially stable, with long periods of alternating light as shadows stretch and change shape over hours and days over hours and days.
The light of two suns is never the same. One star can be hotter and bluer, the other cooler and yellower. Their radiation mixes in the planet's atmosphere, creating unusual color effects. The sky can take on shades that are not found in single systems. At certain points, light becomes so complex that the atmosphere begins to scatter it in unusual spectra, and the surface is under two different types of solar influence at the same time. On such worlds, not only the orbit is important, but also the stability of the binary system itself. If the stars are too close or their masses are very different, gravity becomes chaotic. Then the planets are either ejected from the system or go into extremely unstable trajectories. But if the balance is found, a rare and stable space is formed, where a planet can exist for billions of years.
Sometimes, such worlds are located on the edge of the habitable zone, a region where the temperature allows the existence of a liquid medium. In systems with two suns, this zone is more complicated. It is not fixed, but constantly shifts depending on the position of the stars. The planet seems to be moving inside a changing ring of conditions, where heat and cold replace each other in an unpredictable rhythm. On the surface of such worlds, atmospheric phenomena could exist that are difficult to imagine in solitary systems. Double shadows, intersecting lines of light, slow-moving twilight zones, where one star is already below the horizon and the other is still illuminating the surface from a different angle. Even the perception of time on such a planet would be different. A day would not be defined by a single star, but would be made up of the interaction of two light sources. Sometimes both suns would rise at the same time, creating a powerful peak of illumination. And sometimes one would set behind the other, leaving a soft, diffused light that would last much longer than normal twilight. Such systems are a reminder that space does not seek simplicity. He builds structures that seem almost impossible. Binary stars, complex orbits, planets held in a delicate balance between two powerful gravitational centers. And each such system is not an exception, but another version of how space and motion can exist.
And the deeper such worlds are studied, the clearer it becomes that planets with two suns are not a rare anomaly, but a natural result of complex galactic dynamics, where stars are often born not alone, but in pairs. And entire systems are formed around these pairs, where light never belongs to the same source. If you go further into the depths of such systems, you can encounter even more complex configurations: triple stars, unstable orbital traps, planets that pass through regions with sharply changing gravity. But it is the binary systems that remain the most stable and the most surprising, because in them, chaos and order exist simultaneously without destroying each other. And somewhere out there, among billions of stars, there are still worlds where a single sun never rises above the horizon. In such binary systems, the so-called dynamic stability of the orbits plays a particularly important role. The planet must be at a sufficient distance from both stars so that gravitational perturbations do not destroy its trajectory. If it's too close, the orbit becomes chaotic, and the planet either falls into the system or is ejected into interstellar space. But if a balance is found, a rare type of motion is formed when the planet seems to flow around two gravitational centers at once. Its path is not repeated in exactly the same way, but remains within a stable zone. This creates a sense of constant variability in cosmic mechanics, where there are no perfectly repeating cycles like single stars. In such systems, the effect of variable lighting is often found. As the stars diverge in their orbits, the light becomes softer and more uniform. When they approach each other on the line of sight, the brightness increases sharply, and the surface of the planet receives a powerful flow of energy from two directions at once. This affects the atmosphere. Winds increase, circulation flows change, and long global systems of gas movement are formed. The atmosphere of such worlds can behave extremely unusual. Due to the two sources of radiation, complex temperature gradients arise that are not fixed in stable climatic zones. Instead of the usual belts, constantly shifting areas of heating and cooling appear. This makes the climate dynamic, almost alive in its structure.
Some models show that there may be long periods of relative equilibrium on such planets, when the orbits of the stars and the planet enter a steady phase. Then the climate will stabilize by thousands or even millions of revolutions. But then gravitational interactions displace the system again, and a new cycle of change begins. Unusual processes can also occur inside the planet itself. Temperature differences from different sides of the orbit create internal stresses in the crust, which can increase tectonic activity. The surface becomes subject to constant reconstruction, where landscapes are not fixed for geologically long epochs, but are gradually transformed.
The two stars also affect the radiation spectrum. If one of them is hotter and emits in the blue range, and the other in the yellow or red range, the planet's atmosphere receives a complex superposition of spectra. This can lead to unusual light scattering effects, where the sky takes on unstable hues depending on the position of both stars. Sometimes, both stars can go through stages of activity, creating powerful flares. At such moments, the planet is under a double stream of radiation, which dramatically increases the energy load on the upper atmosphere. This can cause expansion and a temporary change in the density of the gas envelope.
Systems with two suns are often formed as a result of the joint birth of stars from the same gas and dust cloud. Such stars turn out to be gravitationally bound from the very beginning, and their orbital dynamics form along with the planets. Therefore, planets in such systems do not adapt to a binary star, but are formed already in the conditions of its existence. Sometimes binary systems can be unequal. One star is more massive and brighter, the other is smaller and dimmer. In such cases, the planet experiences the asymmetrical effects of light and gravity. This creates the effect of the dominant sun, when one luminary determines most of the climatic conditions and the second only introduces periodic changes. But even with such asymmetry, the system remains complex. At certain points in the orbital motion, the smaller star may be closer to the planet, temporarily changing the balance of light. This creates cycles that can be significantly longer than the normal planetary seasons. Such worlds remind us that stability in the cosmos is not immobility, but a balance of constant change. Two stars, two gravitational forces, many orbital interactions. All this forms a system that lives in constant motion, not collapsing, but holding its shape due to complex dynamics. And somewhere in the depths of galaxies, planets continue to exist, for which two suns are not an exception, but the basis of their world. And the further the movement of such systems develops, the stronger another feature manifests itself. The interaction of light and gravity begins to affect not only the climate, but also the very structure of the orbital space around the planet. In binary star systems, there is a region where the gravitational fields of the two stars create complex resonances. In these zones, movement becomes especially sensitive to the slightest changes. Even a slight redistribution of mass in one of the stars or a slight shift in the orbit of the second can change the trajectory of a planet over time. Therefore, such worlds are often in a state of delicate balance, where stability is maintained not by rigid fixation, but by a constant redistribution of power. It is not a static system, but a dynamic construct that exists only because all the elements are constantly interacting. Sometimes, a planet in a binary system passes through regions where the light of two stars begins to interfere not only visually, but also energetically. Radiation fluxes are superimposed on each other, creating zones of energy intensification and weakening in the atmosphere. This results in streaks of unstable heating that move slowly across the surface. Such bands can exist for a long time, gradually changing the climatic structure of the planet. Excess heat can accumulate in one region, while relative cooling can be observed in another. But unlike single-star systems, there is no fixed seasonality. Everything is determined by the position of two luminaries at the same time. In some cases, the orbital configuration of stars can lead to periods when the planet is in almost symmetrical illumination. Then, both suns rise and fall in approximately the same rhythm, creating an unusual balance of light. But this equilibrium is always temporary, because the orbits of the stars continue to move, and the system again comes out of perfect alignment.
If we consider such worlds on scales of millions of years, it becomes clear that their climatic history is not linear. It is an alternation of phases of stability and phases of restructuring. In stable periods, the surface can maintain stable conditions, and in transitional periods, large-scale changes in atmospheric flows and temperature regimes occur. The two stars also affect the structure of the radiation belts around the planet. The magnetosphere in such conditions is under constant load from different directions, which makes it complex and multi-layered.
Streams of charged particles can form variable belts, which do not exist in a fixed state but are constantly shifting. Especially interesting is the behavior of light in the atmosphere of such worlds. When two radiation sources are at different angles, the scattering becomes multi-component. This creates a shadow overlay effect, where a single object can cast multiple directed shadows at once, depending on the position of the stars.
At such moments, the surface of the planet becomes a space of complex light geometry, where the lines of light and shadow do not coincide with the usual logic of a single source. This creates an ever-changing pattern of illumination that depends on each movement of the stars. Binary stars themselves are not static objects either. They can exchange mass, especially if they are close enough to each other. This process affects their brightness, temperature, and even the orbital stability of the entire system. As a result, the planet finds itself in a system that evolves not only around it, but also on its own. This is what makes such worlds especially difficult to understand. Here, it is impossible to separate the planet from its stellar environment. Everything is connected into a single dynamic structure, where each element affects the other.
And somewhere among these complex interactions, there are still planets for which two suns are not uncommon, but the natural state of their cosmic home. But the most unusual processes begin when the orbits of stars are elongated more than usual. During such periods, the distance between the two suns is constantly changing. Now they approach almost closely, then they diverge for huge distances. For the planet, this means a continuous change in the energy regime of the entire system. As stars come closer together, their combined brightness increases dramatically. The space around the planet is filled with increased radiation. The atmosphere heats up, the upper layers begin to expand, and wind flows accelerate to enormous speeds. But then, the stars diverge again, and the temperature gradually drops, creating a long cycle of instability.
Sometimes, such changes occur so slowly that entire epochs of the planet pass under different levels of illumination. One period can be much brighter than another, and this even affects the chemical processes in the atmosphere. The molecules begin to react differently under the altered spectrum of the two suns, forming complex compounds that rarely arise near single stars. In some binary systems, one of the stars may be a red dwarf, a small but extremely active star. Such stars are known for powerful flares and plasma ejections. If the second star is calmer and larger, the system turns into a constant alternation of stability and sharp energy storms. During flares, the surface of the planet can receive huge doses of radiation. The atmosphere begins to glow, ionized particles penetrate the upper layers of the gas envelope, and the magnetic field is strongly shocked by plasma flows. Giant auroras appear in the sky, covering entire hemispheres.
But even such extreme conditions do not always destroy the system. The cosmos is capable of holding incredibly complex structures for billions of years if orbital mechanics remain stable enough. And that's what strikes me the most. Two suns, powerful gravitational interactions, flares, variable lighting, and in the midst of all this, the planet continues to move in its orbit. Some circumbinary worlds can be covered in dense clouds that reflect the light of two stars at once. Then, the atmosphere begins to play the role of a giant mirror, scattering radiation in different directions. The planet becomes brighter than it would be near a single sun, and its cloud layers acquire a complex structure due to variable heating. If oceans of liquid matter exist on such a planet, their behavior also becomes unusual.
two stars create more complex tidal effects, especially if the orbit is slightly tilted. The masses of the fluid begin to slowly shift in accordance with the gravitational rhythm of the binary system.
Even the sky of such a world itself never remains the same. Sometimes one sun is higher than the other. Sometimes both almost touch the horizon at the same time. And sometimes one star temporarily outshines the other. Then the brightness drops sharply, and the planet plunges into a short period of strange twilight when the light becomes dimmed and colored in unusual shades. In some systems, a planet may pass through a region where two stars are on opposite sides of the sky. Then the surface is illuminated from two directions at once, and the darkness almost disappears. At night, only faint areas of the penumbra remain, because at least one star continues to illuminate the surface.
But there are also rarer configurations where the planet's orbit is tilted relative to the plane of motion of the stars. Then the world periodically goes above or below their orbital level, and the lighting begins to change even more. During such cycles, long periods of cooling or overheating can occur. Galaxies are filled with billions of binary star systems. Many of them have not even been fully studied yet. And among this infinite number of luminaries are hidden worlds, where two suns are an ordinary part of the sky.
Each such system shows how diverse the cosmos can be. There is no single scheme for the formation of planets. There is no single type of star world. The universe creates structures that look almost impossible, but continue to exist in a perfect balance of motion and gravity. And as the binary stars continue their slow rotation around a common center, the planets around them remain witnesses to one of the most unusual phenomena in the cosmos, a world over which two suns shine at once. But even double suns are not the limit of difficulty. In some circumbinary systems, several planets move around two stars at once, and then the entire system turns into a giant mechanism of intersecting orbits, gravitational resonances, and continuous oscillations. Each planet influences the other. Their gravity slowly changes the trajectories of neighboring worlds, creating long cycles of orbital displacements. Sometimes these changes are almost imperceptible, but over millions of years, they can completely rebuild the system. If one of the planets is a massive gas giant, its gravity begins to act as a hidden regulator of motion. It can hold smaller worlds in stable resonances, or conversely, push them into unstable orbits. In some cases, entire planets leave the system and go into interstellar darkness, turning into wandering worlds without a sun. But those that remain continue to move around the two stars, as if the entire system were held in an invisible equilibrium.
The behavior of light in the dense atmospheric layers of such planets looks especially strange. When two suns are close to each other in the sky, their radiation merges, creating an almost single source of light. But when they diverge, the surface begins to receive lighting from different angles, and the atmosphere reacts to this with complex optical effects. Sometimes long arcs of light can occur in the upper layers, caused by the refraction of two stellar streams at once. Clouds are painted in different shades at the same time, and the horizon lines become blurred due to the unusual distribution of light. If one star is hotter than another, then its radiation can gradually change the chemical composition of the atmosphere more than the other. Then, regions with different gas densities appear on the planet, and the atmosphere begins to behave not as a single shell, but as a complex multi-layer system. In some binary systems, the planets are so far from the stars that both suns appear smaller and fainter than the sun from Earth. But even at such distances, their combined influence remains enormous. The light of the two stars still creates unusual cycles of illumination, and gravity continues to drive the motion of the planet. Sometimes, binary stars are surrounded by the remnants of a protoplanetary disk, a huge ring of gas, dust, and icy particles. Such structures can exist for millions of years after the formation of the system. New objects continue to be born inside them: moons, dwarf planets, comets. And then the system becomes even more complex. Icy bodies that cross the orbits of the planets move through it. Comets reflect the light of two suns at once, and their tails change direction depending on the position of the stars.
In the center of all this, the stars themselves continue to rotate. Their movement never stops. They do not hang motionless in space. Each constantly bypasses the common center of mass. Sometimes this movement is fast and close, sometimes slow and wide, but it is this that determines the fate of the entire system. If one of the stars begins to age faster, its structure gradually changes. It can expand, lose its outer layers, or increase in brightness. Then the whole system enters a new phase of evolution. Planets receive more energy, atmospheres are warming, orbital dynamics are beginning to rebuild. In the distant future, some binary systems may experience catastrophic changes. One of the stars turns into a white dwarf, a neutron star, or even a black hole, and then the planet continues to orbit around a completely different type of object. There are theoretical models where the world is still held in orbit even after the transformation of one star into a super-dense object. Then, next to the ordinary sun, a dark source of monstrous gravity appears, bending the space around it. On such a planet, the sky would look almost unreal. One star shines with ordinary light, and nearby is a region where the light is bent and disappears in a gravitational trap. But even such extreme systems continue to obey the same fundamental laws of the cosmos: motion, gravity, and orbital balance. And somewhere in the infinite depths of galaxies, worlds continue to exist over which two suns rise, slowly moving across the sky in an endless dance of light and gravity.